Hi everyone, my name is Ari Lamstein, and today I'm going to talk about mapping ACS data in R with Choroplethr. Before I start, I'd love to see a show of hands who here uses R. So that's a lot more than I thought. I feel a lot better now. Choropleth, I'll just take a moment to talk about R briefly for those of you who don't use R. I think there are three reasons why it's at least worth considering to use. The first is that it's free, and we all like free. The second is it's an excellent tool for exploratory data analysis, and that's mostly what I'm going to be talking about today. And the third reason is there are a lot of user-contributed packages which solve a lot of very common or even very specific problems with data analysis. So, for example, if you wanted to make a choropleth map in R, you might be interested in this package I created, which only makes choropleth maps in R, and it in turn is built using other user-contributed packages. For those of you who don't know what a choropleth map is, it's that exact map you see up there. Any map that shows regions, in this case counties, and expresses values for those regions with color is a choropleth map, and the map you see here is showing the values are population estimates for U.S. counties. I spend a lot of time teaching people how to use R, and especially a lot of time teaching people how to use Choroplethr. And my hope in this talk is that you will learn at least the basics of how to use the package. And this code here is actually the code that generates the map. Everything I'm showing today is code that then generates a map. And the first line for using Choroplethr is you need to install this package. As I mentioned, R has a lot of user-contributed packages. They all need to be installed the first time before you use them. Every time you want to use the package, you need to tell R to load it, and that's what the library command that you see there is. After that, we're actually creating the map. And I designed Choroplethr with the idea, a design principle of it should be absolutely as easy to use as possible. And part of that is shipping with example data. So this line here, data df pop county, it will load 2012 population counts. And that's a data frame. The df stands for data frame. It's just columns with, the first column is a region, county FIPS code, and then you have the value, which is the actual population estimate. And what's the simplest way to tell R to create a choropleth map? Literally a command that says county choropleth with the data frame. If you visit myACStalk.com, that's just a simple page, and you'll see these slides. The slides are already up on the ACS data users group. But if you visit this page, you'll also have an opportunity to download the actual code that is on all of the slides. And in my experience, the best way to learn R is simply to play with someone else's example code. This is a fairly short talk, but I still thought it would be useful to publish an outline. We just finished the introduction where I explained what Choroplethr is and why you might want to use it. Next, I'm going to talk about a case study of using Choroplethr for exploratory data analysis. And then in the last few minutes, I'm just going to rush through all these other features with Choroplethr. So I'd like to think that my talk today is interesting, but there's no way that it is as interesting as this talk that I listened to before. I actually read this book, The Frackers, The Outrageous Inside Story of the New Billionaire Wildcatters, and I learned about it from an interview on Econ Talk, which is a podcast I listen to, and I include the URL there. And if you are interested in demographic changes, I highly recommend that you listen to this podcast. Before listening to this podcast, I knew very, very little about fracking. I knew that there were some environmental problems with it, and that was it. And what this author did was he researched the people who invented the technique, and then he profiled how quickly America changed as a result of fracking. And there are some incredibly vivid examples in the book. A lot of the examples I remember are from North Dakota, because around 2000, North Dakota was not doing very well as a state. And then I'm not a geologist, so I'm going to get the terminology wrong, but there are like these rocks under North Dakota that people knew had oil, but they couldn't extract it. And then fracking was discovered, and people realized we can get really rich by digging oil wells in North Dakota. And that had profound demographic changes on North Dakota. One of the vivid stories is all the stores, these general stores, used to get pallets of goods, and then they'd unpack them and put them on the store shelves. But there was such a population boom, they would just get the pallets, drop them on the aisles, open them up, and they said, just take whatever you want and bring it to the cash register. That's how profound the demographic changes were, how profound the population influx is. And all of these jobs are very high-paying jobs. And I became interested in whether I could use Choroplethr to explore and map these demographic changes. And I found it to be very easy. So this is a percent change in per capita income in U.S. states from 2010 to 2015. And there's a very clear outlier of North Dakota. And I chose these years because Choroplethr uses the Census API to get data, and the first year of ACS data you can get from the API is 2010, and the last year is 2015. A design principle I had with Choroplethr, besides being easy to use, is that the code should, to the extent it's possible, read like English. So if you wanted to run this code, you would need to get an API key from the Census Bureau, which is free. And once you set it, all you have to do is call get state demographics with an end year and a span, and you'll get 8 or 9 very common demographic statistics that people like when they want to just understand various regions, race, ethnicity, and per capita income. Everything in Choroplethr is just a region and a value. That's the minimum data you need to create a choropleth map. You need to know where you're talking about and what values they should have. And so this code here is just specifying we're creating a new column called value that's equal to per capita income. And then this function here, calculate percent change, will just join the data frames, calculate the percent change between the values. And then like before, you just need to call this one function, state choropleth. And here we're adding num colors equals 0. And all that does is specify that you want a divergent scale. And that means that extreme positive values are blue, white means 0, and then red is a negative value. And so you could see here that Nevada had a mild decrease in the period of per capita income. So here we are in the grand scheme of the talk. We finished the introduction and the case study, and now I want to race through some additional features that you might find useful if you decide to try and use Choroplethr. So here I am zooming in on North Dakota counties. All the maps I showed you before were the totality of America. And of course, if you were interested in what's going on in North Dakota, you would want to zoom in. And Choroplethr, everything, there's many, many different types of maps, but they all follow the same convention. So to get the county demographics, you just call get county demographics. You need to set the value, run this code, county choropleth. And if you want to zoom in, you just say state zoom and equal to one or more states that you're interested in. And I just want to briefly point out that continuous scales are great for seeing extreme values, but also here you can see that the states in the Northwest have the highest per capita income. And this is the last time I'm going to talk about oil, I promise. But you can see here that the name of the geological formation under North Dakota is called the Bakken Formation. And you can see that most of the oil wells are in the Northwest as well. Oftentimes, when you're zooming in on small regions, it's useful to overlay a choropleth map over a map from Google Maps. For example, I wouldn't recognize what North Dakota looks like. I also wouldn't know where the major cities are or where their major roads are. Choroplethr, as I mentioned earlier, everything is just a single function call to create a map. And this line of code here, reference map equals true, will superimpose your choropleth map over a map from Google Maps. A recent functionality I added to Choroplethr is the ability to map census tracts from every state. And here I'm shifting from North Dakota to Manhattan simply because North Dakota doesn't have a lot of, has a low population, and so the zip code maps and the county maps and the tract maps all kind of blur together. But in a county like Manhattan, you can see a lot of patterns. And so again, to get those 8 or 9 variables, you just need to call get tract demographics and then call the function tract choropleth. And if you want to zoom in on a county, you just need to specify the FIPS code. And there's some really interesting things about this map. There's a giant hole in the middle of Manhattan, for example, and right next to that hole on the east side, you can see there are a lot of very high income tracts where the per capita income of about $250,000. And I happened to grow up in New York, so I knew that hole was Central Park. But for those of you who didn't, the reference map parameter really does help, and you can see that very rich neighborhood over there is the Upper East Side. The last bit of functionality in Choroplethr that I want to point out is the ability to map zip codes or zip code tabulation areas. This is a very large map, and so it's actually in a separate package called Choroplethr zip. But again, the conventions are the same. So just get zip demographics, setting the value to be what you'd like, and then calling the function zip choropleth to make a map, and again with county zoom. And you can see this is Manhattan again. And it's actually interesting to compare the tract map with the Zicta map for Manhattan. And again, it's very easy to overlay the map over a Google map. As I mentioned earlier, I spend a lot of time teaching people how to use R and how to use Choroplethr. I have a free course called called Learn to Map Census Data in R, actually. It's at the URL censusmappingcourse.com. And if you take the course, you get 1 email a day for a week that has a lesson as well as a little homework assignment. And if you click reply on the email with your homework, I'll give you feedback on it. And lastly, I wanted to remind you that the slides and the code are available at myacstalk.com. Thank you very much.